Hello students, welcome to Diksha Karnataka YouTube channel. In this video, I am going to discuss solution of the mock test 3 for COMEDK 2024. Mock test 3 has been released, right? So in this video, I will discuss physics part 1, question 1 to question 30. Okay, yeah. So let us start. Question number 1. Question number 1. Out of the following pairs, which one does not have identical dimensions? Okay, out of the following pairs, which one does not have the identical dimensions? Right? Okay, let's check each option. Option A says moment of inertia and moment of force. So what is the dimension of moment of inertia? The dimensional formula for moment of inertia is m into L square, right? Formula of the moment of inertia is mr square, right? So the dimension formula of moment of inertia is m into L square. Okay, so then the moment of force. Moment of force is nothing but torque, right? So what is the dimension formula of the torque? The dimension formula of the torque is m L, okay, ml t to the power minus 2. Okay, ml t to the power minus 2 into L. So that is ml square t to the power minus 2. Okay, so here these two pairs does not match, right? Isn't it? Moment of inertia and moment of force does not match. So option A is correct. Okay. Option B, work and torque. So what is the dimension formula of the work? Dimension formula of the work is same as dimension formula of the torque, right? F into S, isn't it? So these two will pair. Okay. Option B is wrong. So let's check option C, angular momentum and Planck's constant. Again, these two, dimension formula of the angular momentum is same as dimension formula of the the Planck's constant, right? So you know the formula, right? Angular momentum of the electron in Bohr's orbit L equal to nh divided by 2 pi. So what is n? Principal quantum number. So it is dimensionless, and 2 pi is also dimensionless. So the dimension formula of the L is same as dimension formula of the h, right? So option C is also wrong. Option D, impulse and momentum. Impulse is nothing but change in momentum, right? So the dimension formula of impulse is same as dimension formula of the momentum. So the correct option is A. Question number 2. In 1 second, particle goes from point A to point B moving in a semicircle of radius 1 meter. Okay, let us draw the diagram. Here, this is the semicircle. This is point A. Here, the point B. Particle goes from point A to point B. Okay, so the radius of the semicircle is 1 meter. So the diameter will be 2 meter. The diameter is 2 meter, right? Diameter is 2 meter. The magnitude of the average velocity of the particle is, so magnitude of the average velocity of the particle is equal to magnitude of the total displacement, right? So magnitude of the total displacement by time interval, right? So what is the time interval? 1 second. So what is the total displacement? 2 meter, right? So V average is equal to 2 divided by 1, which is equal to 2 meter per second. The correct option is B. Okay. Question number 3. If wavelength of maximum intensity of radiation emitted by sun and moon are 0.5 into 10 to the power minus 6 meter and 10 to the power minus 4 meter respectively, the ratio of the temperature is. Okay, so we need to find the ratio of the temperature, right? Here apply Wien's displacement law, right? So Wien's displacement law says that here the wavelength of the emitted radiation is inversely proportional to the temperature, right? Or absolute temperature, isn't it? Inversely proportional to the temperature. That is lambda m into T equal to constant, right? Lambda m into T is equal to constant, isn't it? Lambda m is maximum wavelength. Okay. Now maximum wavelength emitted by the sun and moon are 0.5 into 10 to the power minus 6 meter and 10 to the power minus 4 meter, right? So here lambda m of lambda m of sun divided by lambda m of moon is equal to T of moon divided by T of sun, right? T of moon by T of sun. So we need to find T of sun by T of moon, right? So T of sun divided by T of moon is equal to, here T of sun is 0.5 into 10 to the power minus 6, right? 0.5 into 10 to the power minus 6, right? Divided by here 10 to the power minus 4, 10 to the power minus 4, right? So T of sun divided by T of moon is equal to, here 1 divided by 2 into 10 to the power minus 2, right? Okay, we need to find the ratio of the temperature of the moon to sun, right? So T of moon to T of sun is equal to 2 into 10 to the power 2 divided by 1, that is 200 is to 1. Okay, 200 by 1, that is 200 is to 1. So the correct option is C. Question number 4. A body is allowed to fall from a height of 100 meter. A body is allowed to fall from a height of 100 meter if the time taken by the first 50 meter is t1 and for the remaining 50 meter is t2, then. Okay, let us draw the diagram. Here, this is the 100 meter building. Okay, so body takes time t1 to cover first 50 meter distance, and then body takes time t2 cover 50 meter distance, another 50 meter distance. Okay, so now we need to find the relationship between t1 and t2. Okay, so now let us find t1. Apply second equation of motion. What is the second equation of motion? H equal to ut plus half a into t square. In this case a is g, so g into t square. U is 0, right? So h by g equal to t1 square, right? So t1 equal to h equal to, here 50 meter, g is 10 meter per second. So solve this, you will get root 10 second. Okay, root 10 second. Okay, we got the value of t1. So let us find t2, right? So now what is the total time taken by the body to cover 100 meter distance or 100 meter height? T1 plus T2, right? Again apply second equation of motion, right? So now here h equal to 100 meter, right? So now 100 equal to initial velocity of the body is 0 into half g into t1 plus t2 whole square, right? So now t1 plus t2 is equal to 2 into 100 is 200, 200 by g is, that is 10 is 20. So root 20 is 2 into root 5, 2 into root 5 second, right? 2 into root 5 second. So we need to find the value of t2, right? So now t2 is equal to 2 into root 5 minus root 10, 2 into root 5 minus root 10, isn't it? So now if you observe this, here the value of t into root 2 minus 10, right? T into root 5 minus 10, right? Root 5 is almost equal to 2, right? So this is 4 minus root 10 is almost equal to 3. So it is approximately equal to 1, right? T2 is approximately equal to 1. And what about the T1? T1 is approximately equal to 3 second, right? Isn't it? So from this I can conclude that T1 is greater than T2. So the correct option is B. Question number 5. A wall is made of equally thick layers A and B of different materials. Okay, equally thick layers, and it is made up of different materials. So this is D and D. Okay, equally thick layers. So here area will also be same, A and A, right? And it is made up of different materials. thermal conductivity of A is twice that of B. So thermal conductivity of A is twice that of B. Okay. In the steady state, the temperature difference across the wall is 36 degrees Celsius. Okay, so this is the temperature at A is theta A, okay, and theta is temperature at the junction, and theta B is temperature at B, right? So here this is area, okay, so this is small a and this is small b. Small a and small b, okay. 36 degrees Celsius, that is theta A minus theta B equal to 36 degrees Celsius, right? The temperature difference across the layer is, that is we need to find the value of theta A minus theta, okay, theta A minus theta. So now apply heat current. So we know that heat current H equal to thermal conductivity K into area A into theta 2 minus theta 1 divided by D, right? So this is the heat current. Here heat current at A is equal to heat current at B, right? So theta is the common temperature, right, or temperature at the junction. So now H1 equal to H2, right? H1 equal to H2 or HA equal to HB. HA equal to HB. HA equal to HB. So what is HA? So KA, okay, KA into A into theta A minus theta divided by D, which is equal to KB into A into theta minus theta B divided by D. So A by D will get cancelled, right? So now KA equal to 2 times KB, right? So now 2 times KB into theta A minus theta B, sorry, theta A minus theta equal to KB into theta minus theta B. So now KB will get cancelled, right? Then add theta A minus theta to both sides, okay? Add theta A minus theta to both sides. Here 2 times theta A minus 2 theta, then add theta A minus theta to both sides plus theta A minus theta is equal to theta minus theta B plus theta A minus theta, okay. So now this will be 3 theta A minus 3 theta is equal to, here theta will get cancelled, theta A minus theta B. We need to find theta A minus theta B. So which is equal to we need to find theta A minus theta, right? Theta A minus theta, which is equal to theta A minus theta B divided by 3. So what is theta A minus theta B? 36 degrees Celsius, right? So finally theta A minus theta is equal to 12 degrees Celsius. The correct option is A. Question number 6. Two bodies are thrown up at angles of 45 degrees, 60 degrees respectively with the horizontal. If both bodies attain the same vertical height, then the ratio of velocities with which these are thrown is, okay. So both bodies attain same vertical height, right? That is maximum height attained by the first body is equal to maximum height attained by the second body. So what is the maximum height formula? U square sin square theta divided by 2g, right? So h max 1 will be u1 square into sin square theta 1 divided by 2g, okay. So which is equal to u2 square sine square theta 2 divided by 2g. So now 2g will get cancelled, right? So what we need to find? We need to find the ratio of the velocities, right? That is u1 square divided by u2 square is equal to sine square theta 2 divided by sine square theta 1. So what is the value of theta 2? 60 degree. Theta 1 is 45 degree, right? Now take square root on both sides. Okay. So now u1 divided by u2 is equal to sine theta 2, sine 60 degrees root 3 by 2 whole divided by sine theta 1, right? Sine theta 1 is here sine 45 degree. Sine 45 degrees 1 by root 2. Okay, 1 by root 2. So u1 divided by u2 is equal to, solve this, you will get root of 3 by 2. So the correct option is C. Okay, root of 3 by 2. Question number 7. 400 cubic centimeter volume of gas having gamma, that is specific ratio of the specific heats, okay, 5 by 2 is suddenly compressed to 100 degrees Celsius, 100 cubic centimeter. If the initial pressure is P, then the final pressure will be, okay, we need to find the final pressure, right? So we know that in adiabatic condition, okay, adiabatic condition, PV to the power gamma equal to constant. PV to the power gamma equal to constant. Okay. So here P1 equal to P. We need to find P2 or P dash. Okay. And here this is V1 and this is V2. Okay. Now P1 V1 to the power gamma is equal to P2 V2 to the power gamma. P2 is P dash, right? We need to find P dash. So P dash is equal to P1 is P into V1 divided by V2 whole to the power gamma. So now P dash is equal to P into V1, that is 400 degrees Celsius, 400 cubic centimeter divided by V2 is 100 cubic centimeter whole to the power 5 by 2. Now 100 will get cancelled. Okay. So now 4 to the power 5 by 2, right? So what is the root of 4? 2. So then 2 to the power 5 is 32, right? So now P dash is equal to 32 times P. So the correct option is C. Question number 8. A spring of force constant 800 Newton per meter has an extension of 5 centimeter. Okay. It has an extension of 5 centimeter. Okay. So the work done in extending from 5 centimeter to 15 centimeter is, okay. So here the spring constant is given, right? K is given. Here the spring is already extended, that is potential energy is already stored, right? So now we are extending it from 5 centimeter to 15 centimeter, right? So we need to find the work done in extending it from 5 centimeter to 15 centimeter, right? So we know that work done by this spring force W equal to half K into x square, right? Half K into x square. So now W is equal to half into here K into x is x2, x square is x2 square minus x1 square. So this is x2 square minus x1 square. So now W is equal to half into K is 800 Newton per meter into x2 square, that is 225 centimeter squared, okay, 225 centimeter squared minus 5 centimeter square is 5 centimeter whole square is 25 centimeter squared. So into 10 to the power minus 4. Now this is 200, right? So W is equal to 200 by 2 is 100. 100 into 800 is 8 into 10 to the power 4 into 10 to the power minus 4. joule. Finally, W is equal to 8 joule. The correct option is B. Question number 9. If the air column in a pipe which is closed at one end, okay, is in resonance with the vibrating tuning fork at a frequency 260 hertz, then the length of the air column. Okay, we need to find the length of the air column, right? One end of the air column is closed, right? So therefore, the fundamental frequency nu will be equal to V divided by 4L, right? V divided by 4L. We need to find the length of the column. Now L equal to V is this velocity of the sound in air divided by 4 into nu. So now L equal to V is 330 divided by 4 into 260, right? So 4 zeros are 0, so then 6 fours are 24, right? And then 4 twos are 8 to 10, okay, 1040, right? So now L is equal to, okay, so now take here multiply and divided by 10, okay, multiply and divided by 10, then this is 3000 here, okay, sorry. So multiply and divided by 10, or you can solve it like this. Here 10.40 into 10 to the power 2. Okay. So now 330 divided by 10.40, right? So this is almost equal to 35.7, right? 31.7, right? So this is almost equal to 31.7, and then into 10 to the power minus 2 is here, into 10 to the power minus 2, that is centimeter. Now L equal to here 31.7 centimeter. The correct option is B. Okay, 31.7 centimeter. Question number 10. Which of the following is an expression of power? Okay, so they have given power in terms of omega and tau, right? That is, we need to find the power of the rotating body, right? So we know that power is equal to rate of change of work done, right? Rate of change of work done. And work done to rotate the body, W is equal to tau into d theta, right? Torque into angular displacement, right? Yeah. So now here P is equal to d of tau into d theta divided by dt. So now P equal to here tau into theta, okay, not d theta, it is tau into theta, that's it, tau into theta. Okay, so now P equal to tau into d theta divided by dt, right? Tau into d theta divided by dt. So what is d theta by dt? D theta by dt is angular velocity, right? So now P, that is power, is equal to tau into omega. So the correct option is A. Okay. Question number 11. A body constrained to move in y direction is subjected to a force given by F vector equal to 2 minus 2i cap plus 15j cap plus 6k cap Newton. The work done by this force in moving the body a distance of 10 meter along the y-axis. Okay, it is constrained, the body is constrained to move along y-axis only. Okay, so we need to find work done by this force, the given force, in moving the body a distance of 10 meter along y-axis, right? Isn't it? So what is work done? Work done is equal to F dot S, right? So work done is equal to force is here minus 2i cap plus 15j cap plus 6k cap dot S vector is here 0 I cap plus 10 j cap plus 0 k cap. Now solve this, you will get W is equal to 150 joule. The correct option is B. Question number 12. A particle performing uniform circular motion has angular momentum L if its angular frequency is doubled and its kinetic energy is halved. Okay, so L is the angular momentum, okay, and the angular frequency is doubled and its kinetic energy halved. Angular frequency is omega, okay. Its angular frequency doubled, right? That is omega dash is equal to 2 omega and kinetic energy halved. K is the kinetic energy, so K dash is equal to K divided by 2. K is the initial kinetic energy. Then the new angular momentum is, so we need to find the value of L dash or expression of L dash. Okay, we know that the rotational kinetic energy K equal to half I into omega square. Okay, and we also know that angular momentum is L equal to I into omega. Angular momentum of the rotating body is I into omega. So now I can write K, that is kinetic energy, in terms of angular momentum, right? So K equal to half into I omega into omega, that is L into omega, right? So now L equal to 2K divided by omega, right? So now L dash is equal to 2K dash divided by omega dash. Now L dash is equal to 2 into K dash. K dash is K by 2, right? K divided by 2, right? K divided by 2 whole divided by omega dash. Omega dash is 2 omega. Now L dash is equal to here 1 by 2 into 2, right? So that will be 1 by 4. So now 2 K by omega into 1 by 4. So what is 2K by omega? L, right? So L dash is equal to L divided by 4. The correct option is A. Question number 13. If the metal bob of a simple pendulum is replaced by a wooden bob, then its period will be. So it doesn't matter, right, whether it is a metal bob or simple wooden bob. Why? Because the here time period of the simple pendulum does not depend on the material of the bob, right? T equal to 2 pi into root of L by G. Time period of the simple pendulum depends on the length of the string, right, and acceleration due to gravity. It does not depend on the what metal you are using for bob, right? So the correct option is C, remain the same. Question number 14. Two satellites of masses m and 9m are orbiting a planet in a circular orbit of radius r. Their frequency of revolution will be in the ratio. We know that Kepler's third law, T square is directly proportional to r to the power cube. So that is, the time period or frequency of the revolution of the satellite does not depend on the mass of the satellite, right? So therefore here the frequency of revolution will be in the ratio of 1:1 only. So the correct option is C. Question number 15. A tuning forks A and B vibrating simultaneously produces 5 beats. Okay, it produces 5 beats. Frequency of B is 512 Hertz. It is seen that one arm of A is filed, then the number of beats increases. Okay, the number of beats increases, so we need to find the frequency of the A. Okay, so here when the one arm of A is filed, the number of beats increases, right, isn't it? So let us find the range of the frequency of A. Okay, so the range of the frequency of A will be equal to 512 plus or minus 5, right? So which is equal to here 517, either it is 517 Hertz or 507 hertz, right? Either it is 57 hertz or 507 hertz. But in the question, they said the number of beats increases, right? When you file the one arm of A, what happens? The number of beats increases. That is, the frequency will also be increases, right? So the frequency of the A must be 517 hertz, right? So the correct option is C. Yeah. Question number 16. 2-point charges exert on each other a force F when they are placed r distance apart in air. When they are placed r distance apart in medium of dielectric constant K, they exert same force. Okay, they exert same force. The distance r is equal to. Yeah, so two charges, okay, two charges Q1 and Q2, okay, are separated by distance d. Sorry, r, right? It is separated by distance r. Okay, so now what is the force between Q1 and Q2? It is F, right? So F equal to Q1 into Q2 divided by 4 pi epsilon naught r square. This is F, right? Yeah. So now these two charges are placed in the dielectric medium of dielectric constant K, but the force between them is same, right? That is, the distance between the Q1 and Q2 has been changed, right? Okay, so now in the medium, right? So this is Q1 and Q2. Distance between them is r dash. Here the dielectric constant is K. Force between them is same, that is F dash is equal to F, right? So F dash is equal to Q1 into Q2 divided by 4 pi epsilon naught K into r dash squared. Okay, r dash square. R dash square, sorry, here r dash. Yeah, r dash squared. F dash equal to F, right? Isn't it? So Q1 into Q2 divided by 4 pi epsilon naught r square is equal to Q1 into Q2 divided by 4 pi epsilon naught into K into r dash square. So Q1 Q2 divided by 4 pi epsilon naught and Q1 Q2 divided by 4 pi epsilon naught will get cancelled. Okay, so r dash is equal to capital R. Now r squared is equal to small r square divided by K. So capital R is equal to r divided by root K. R divided by root K. So the correct option is A. Question number 17. If a potential difference between the capacitor 6 microfarad is changed from 10 volt to 20 volt, then increase in energy is. Okay, we need to find increase in energy, right? So increase in energy is equal to final energy minus initial energy, right? Final energy stored in the capacitor and minus initial energy stored in the capacitor. We know that energy stored in the capacitor U is equal to half C into V square, right? Half C into V square. So now increase in energy delta U equal to, take half C as common, okay? So then Vf square minus Vi square. Vf is 20 volt, Vi is 10 volt. So now increase in energy delta U is equal to half into C is 6 into 10 to the power minus 6 Vf square, that is 400 minus Vi square, that is 100. Now delta U is equal to, here 2 3s are 6, 400 minus 100 is 300, right? So now 300 into 3 is 900. So solve this, you will get 9 into 10 to the power minus 4 joule. The correct option is D. Question number 18. The electric field E, current density J and conductivity sigma of a conductor are related as. Okay, so we know that the current density J is equal to current density J is equal to conductivity of the conductor sigma into electric field E, right? So now sigma equal to J divided by E. So the correct option is B. Question number 19. For a circuit, equivalent capacitance, the equivalent capacitance between points A and B is, okay, we need to find, points P and Q is. So we need to find equivalent capacitance between P and Q. And let us redraw this circuit diagram, okay. So this is point P, okay. So this is C1, C2, C3, C4, C5 and C6. Okay, all of them have equivalent capacitance. Okay, all of them has C. Okay, capacitance has C. So now here C1, right? C1 is connected, one plate of the C1 connecting to point P, right? Connected to point P, and then another plate connected to the other one plate of the capacitance C, right? One plate of the capacitance C2 or capacitor C2. So this is C1, okay, C1, and then this will be C2, right? This will be C2, and then the first plate of the capacitor C1 is connected to the first plate of the capacitor C3, right? Then it will be C3, and the C3, the last plate of the capacitor, is connected to the C1 and C2, right? Here this one, like this, okay. Similarly for C4 and C5, here this is the circuit diagram, C4 and C5, these two are in parallel, then it is in series with C6. So this is Q, point Q. This is the equivalent circuit diagram, okay. So now these three are in parallel, right? So therefore equivalent capacitance will be 3C. Point P, here this is 3C, and then this is 2C, and then this is C, Q, okay. So now equivalent capacitance between P and Q is equal to, solve this, you will get, it is in series, right? So 1 by 3C plus 1 by 2C plus 1 by C, okay, solve this, you will get 6C divided by 11. The correct option is D. Question number 20. A hollow metal sphere of radius 5 cm is charged such that the potential on its surface is 10 volt. The potential at the center of the sphere is, okay, we need to find potential at the center of the sphere, right? So this is the hollow metallic sphere, okay, and here it is 5 cm, the radius is 5 cm. On the surface of the hollow metallic sphere, the potential is 10 volt. So we need to find potential at the center of the sphere, hollow sphere, right? Here inside the hollow sphere, electric field is 0, right? We know that electric field is equal to minus dou V by dou R, minus dou V by dou R. This is the relationship between electric field and the potential, okay. So now here electric field is 0, okay, therefore the potential will be constant, right? Why it is constant? Because differentiation of constant will be 0, right? Isn't it? Differentiation of constant is 0, so electric field is 0, so potential is constant. So at the center the potential is 10 volt only, that is as same as the potential on the surface of the metallic hollow sphere. So the correct option is B. Question number 21. A negatively charged oil drop is prevented from falling under gravity by applying a vertical electric field 100 volt per meter. So this is the oil, okay. Mass of the oil is m, it is negatively charged. The force due to gravity acting on this oil is mg, okay. So here it is prevented from falling under the gravity. That is, this force mg is balanced by the electric force, right? So the direction of the electric field must be downwards. Okay, so this is the direction of the electric force QE. If the mass of the drop is 1.6 into 10 to the power minus 3 gram, that is m equal to 1.6 into 10 to the power minus 6 kg. The number of electrons carried by the drop is, okay, we need to find the number of electrons carried by the drop. Here mg is equal to QE. mg is equal to Q into E. So what is Q? N into E, the total charge in the oil. So Q equal to N into E. So E here N equal to N equal to N equal to Q, sorry, mg, okay, mg divided by small e into capital E, right? So N equal to M is 1.6 into 10 to the power minus 6. G is 10 divided by E is 1.6 into 10 to the power minus 19 into E, that is 100 volt per meter. So solve this, you will get N equal to 10 to the power 12. The correct option is C. Question number 22. Three charges Q0, minus Q and minus Q are placed at the vertices of an isosceles right angle triangle as in the figure. The net electrostatic potential energy is 0 if Q0 is equal to, okay, the net electrostatic potential energy is 0, right? That is U net is equal to 0. So we need to find the value of Q0, right? So let us write the net electrostatic potential, right? So electrostatic potential energy or interaction energy between minus Q and Q0. So that will be here K into, okay, so this is isosceles triangle, right? Here the length is L and L. So what about the hypotenuse? Root 2L. And the interaction energy between minus Q and Q0, this Q0 is same as this minus Q and Q0, right? So now I can write it as 2 into K into Q0 minus Q divided by L. This is the interaction energy between Q0 and these two minus Qs, right? Plus interaction energy between minus Q and minus Q. So that will be K Q square divided by root 2 times L, which is equal to 0. So now solve this, you will get Q0 is equal to Q divided by 2 root 2. The correct option is C. Question number 23. The potential gradient along the length of the uniform wire is 10 volt per meter. So that is K is equal to 10 volt per meter. Okay. B and C are 2 points at 30 centimeter and 60 centimeter on a wire on a meter scale along the wire. Okay, there are 2 points, okay, at 30 centimeter and 60 centimeter on a meter scale along the wire. The potential difference between B and C, right? The potential difference between B and C. Here the potential gradient K equal to V divided by L, right? So now here what is the distance between point A and B, right? So the distance between point A and B is 60 minus 30, which is equal to 30 centimeter. 30 centimeter. So this is L, right? We need to find V, that is potential difference. Here K is given, right? So 10 volt per meter is equal to V divided by 30 centimeter, right? 30 centimeter, that is 30 into 10 to the power minus 2. So solve this, you will get V equal to 3 volt. 3 volt. This is the potential difference between point B and C. The correct option is A. Question number 24. The figure shows stopping potential Vs and frequency nu for two different metallic surface A and B. The work function of A as compared to that of B. Okay. So here x-axis represents frequency, y-axis represents potential, stopping potential. We know that stopping potential is directly proportional to the frequency of the incident light, isn't it? So therefore, the work function of A is lesser than work function of B, isn't it? Work function of A is lesser than work function of B, right? Because here the threshold frequency for A is lesser than threshold frequency for B, right? So the work function of A as compared to that of B is less. Option A is the correct answer. Question number 25. Figure shows currents in a parts of an electric circuit, then current I is. Okay, so we need to find current I, this current, right? So apply KCL, the sum of the algebraic current, right? Algebraic sum of the current entering into the junction is equal to the exiting from that junction, right? So here the total current is 4 ampere. Total current is 4 ampere. Now here the current will divide, right? 1 ampere goes to this way, okay, and then the remaining will be 3 ampere. Then 1.3 ampere goes this way, okay, so the remaining will be here 1.3 ampere, right, isn't it? So this is 4 ampere, then 3 ampere, then 1.3 ampere goes this way, right? So the remaining will be 1.7 ampere. The correct option is A. Okay, 3 minus 1 is 2, 2 minus 0.3 is 1.7. Yeah, the correct option is A. Question number 26. The EMF of a cell is E and its internal resistance is R. Its terminals are connected to the resistance capital R. The potential difference between the terminals is 1.64 R equal to 4 ohm and 1.8 volt for R equal to 9 ohm then. Okay, we know that the current in the circuit I equal to E, that is EMF of the cell divided by R plus R, right? So now the potential difference or terminal potential difference, right? Terminal potential difference will be here V equal to I into R, right? So V equal to I is E into R divided by capital R plus small r, right? Now the potential difference between the terminals is 1.6 volt for resistance, that is external resistance is equal to 4 ohm, right? So now here 1.6 volt is equal to R is 4 ohm, 4 into E divided by 4 plus R. So this is the first equation. And then 1.8 volt is equal to 9E divided by 4 plus R. This is the second equation. So now divide second equation by first equation. So then you will get R equal to 1. Okay, R equal to 1 ohm. Okay, then substitute the value of R to any one of this equation. Okay, so then you will get E equal to 2 volt. The correct option is B. Okay, correct option is B. Question number 27. A wire of resistance R is stretched till its length is doubled at the original wire. Here the wire of the a wire of resistance R is stretched. Okay, this wire is stretched. Okay, till its length is doubled. Okay, length of the wire is doubled of the original wire, then the resistance of the stretched wire. Okay, so we have stretched this wire, right? But the volume of the wire remains same, right? Volume of the original shape of the wire is same as the volume of the new shape of the wire, right? So therefore here we know that R equal to rho L divided by A. Now multiply and divided by L. Rho is resistivity, L is length of the wire, A is area of cross section of the wire, R is resistance of the wire. So R equal to rho L divided by V. A into L is volume of the wire. Volume of the wire remains same, right? So this is L square, rho L square divided by V. Now R is directly proportional to L square. Volume of the wire remains same, right? Yeah. So now the length is doubled, right? Now R dash new resistance divided by old resistance or original resistance is equal to L dash square, that is 4L square divided by L square. So now R dash is equal to 4R. The correct option is B. Question number 28. An electric heating element consumes 500 watt 500 watt when connected in 100 volt line. If the line voltage becomes 150 volt, the power consumed will be, okay, the resistance of the electric heating element is constant, right? We know that P equal to V square divided by R. So R is constant, isn't it? So P is directly proportional to V square, right? So now P2 divided by P1 is equal to V2 by V1 whole square, right? So now P2 is equal to P1 into V2 divided by V1 whole square. So now P2 is equal to P1 is 500 watt into V2. V2 is 150 divided by V1 is 100 whole square. So now solve this, you will get 1125 watt. 1125 watt. So the correct option is D. Question number 29. A circuit is as shown in the figure, then the current from A to B is. Okay, we need to find current from A to B, right? Okay, first let us denote the current in this wire. Okay, so this is I1, okay, current I1, okay, current I1, and here the current I2, here the current I2, okay. So then the remaining will be I1 minus I2, I1 minus I2, okay. So now apply KVL rule for first loop and KVL rule for second loop, okay. Apply KVL rule for first loop and second loop. So now apply KVL rule for first loop, okay. So now here this will be plus 10 volt, right? You are moving from this point to this point, right? That is lower potential to higher potential, 10 volt, okay. And then the direction of the current and the direction of the loop is same. So therefore the potential difference across the 10 ohm is negative. So 10 into I1, okay. And then the direction of the current and direction of the loop is same for this 10 ohm, okay. Again the potential difference will be negative. So minus 10 into I1 minus I2. So which is equal to 0. KVL rule, okay. KVL for first loop, okay, first loop. So now here minus 10 I1 minus 10 I1 is minus 20 I1, right? So 10 minus 20 I1 minus 10 I2 is equal to 0. So therefore here 2 I1 minus I2 is equal to 1, okay. So first equation. Then apply KVL rule for second loop, okay. KVL for second loop. Now you are moving from this point to this point, right? That is lower potential to higher potential. So 5 volt, positive 5 volt, okay. Minus, sorry, we don't know it is minus or plus, okay. Then you are moving, okay, the direction of the loop and the direction of the current is opposite, right? So therefore the potential difference across, according to the sign convention, the potential difference across this 10 ohm will be positive, right? So plus 10 into I1 minus I2, okay, I1 minus I2, and then the direction of the loop and direction of the current is same for 15 ohm resistor. So therefore the potential will be negative, so minus 15 I2, so which is equal to 0, okay. So now 10 I1 minus 10 I2 minus 15 I2, so that will be minus 25 I2, right? So 5 plus 10 I1 minus 10 I2 minus 15 I2 is equal to 0, okay. So now 5 equal to 10 I1 minus 25 I2, sorry, this is plus, okay. 10 I1 minus 25 I2 is equal to 0. Now here 5i2 minus here 2i1, right? 2i1 is equal to 0. So this is the second equation. So now solve first and second equation. Okay, now solve first and second equation. Then you will get i2 minus i1. Okay, sorry, i1 minus i2, not i2 minus i1. Okay, i1 minus i2, i1 minus i2 is equal to 250 milliampere. 250 milliampere. Solve first equation and second equation. You will get i1 minus i2 as 250 milliampere. So the correct option is B. And the last question. The ratio of de Broglie wavelength of proton and alpha particle which have been accelerated through the same potential difference. Okay, so which have been accelerated through the same potential difference, right? That is the kinetic energy of the charged particle, that is alpha particle and proton, increases when it is accelerated through a potential difference, and electrical potential energy decreases, right? So gain in kinetic energy is equal to loss in potential energy, right? So we know that kinetic energy is equal to square of the momentum divided by 2m, which is equal to q into v. So momentum p equal to root of 2m into q into v, right? And de Broglie wavelength lambda is equal to h divided by p. So lambda is equal to h divided by root of 2m qv. Root of 2m qv. Okay. So here h is constant, right? And it is accelerated through the same potential difference, right? So v is also constant. So lambda is directly proportional to 1 divided by root of m into q. Okay. So now the ratio of the de Broglie wavelength of proton to the alpha particle is equal to root of mp into qp divided by root of m alpha into q alpha. M alpha is mass of the alpha particle, q alpha is mass of the charge of the alpha particle. Ratio of de Broglie wavelength of proton to the alpha particle is equal to root of here mp into qp divided by 4mp into 2qp. So now mp qp will get cancelled. Why it is 4mp? Because mass of the alpha particle is 4 times mass of the proton and charge of the alpha particle is 2 times charge of the proton. So now lambda p divided by lambda alpha is equal to 1 by 2 root 2, right? So 1 by 2 root 2. Okay, so they are asking the de Broglie wavelength of proton and alpha particle, right? But they have given 2 root 2, that is the ratio of the lambda alpha to the lambda p. Okay, sorry, here the ratio of the lambda alpha to the lambda p, that is 2 into root 2. The correct option is C. Okay, thank you so much for watching this video. If you love this video, please like and share, and if you want to watch more such videos, please subscribe. Thank you.